The next case study is benchmarking performance. We'll start by looking at the Bone Spring in the Delaware Basin. The objective here, and this is the very first, one of the first big projects that Dave and I started when we started at NCS Multistage, is that our objective was to compare pinpoint technology to the incumbent plug-and-perf design. And most of you who are familiar with NCS Multistage understands that they are a very popular vendor of pinpoint technology. So we were brought in at a series of projects studying the impacts of completion type from one well to another, and using our skill sets in rate transient analysis to objectively identify performance issues. So in this study, we looked at 6 sections where each of the sections had both completion types. This is just an example of a single section, just to keep the message short and sweet. We chose a small area in order to limit the geological variations in conducting this study. And we used control variables. And by this I mean we didn't want to compare wells that could have well performance effects as a result of wells with different azimuth or different landing depth. So we made sure to bin things appropriately. We studied the one plug-and-perf well in red in the bottom, and the 2 pinpoint wells that came on stream a few years later, the upper left-hand part of the section. The well spacing was 4 wells per section in this case. The plug-and-perf well was used to characterize a reservoir, and it was treated as the benchmark model because it had the most data. The benchmark model could be whatever well you want, but we typically choose the one that has the most performance history. In this case, what the well was assigned to drain was not uniform. You can see that the well, with respect to the acreage that it's assigned to drain, was a little non-uniform. So, but we can take that into account through modeling. And you can see we've got a really good history match through the flowing pressures indicated in the bottom left-hand plot as the brown line, which is the model response, goes through the data points. In the top right-hand plot, it might be hard to see, but this is a plot of rate versus cum, and the data points, the red dots, are how the well actually performed, and the green scratchy stuff through it that matches it is the model response for cum. So really this is just demonstrating that the final cumulative production matches the simulated. We have a good history match, and we've also presented a linear flow specialized plot, call it a square root time plot type curve, if you will, through the data. Now once we've characterized the rock, now we can play our what-if scenarios, and this is how we do our benchmark. We look at the very first pinpoint well, and that first pinpoint well had a couple stages, or a few stages, that we couldn't achieve breakdown. Maybe there was a screen out or something, I'm not sure, but for whatever the reason those stages were skipped. And yet we can see that the prediction of our previous reservoir characterization would suggest that where the flowing pressures should have been on this well was indicated by that brown line that you can see there in the image in the bottom left. That brown line is where the pressure should be, but the data actually outperforms that. The data, or the dots that are sort of shaded off in light gray, that's where the well actually performed, in the sense that higher pressure means the well outperformed its type curve expectations. So this could be attributed to a few factors, but this is how we sort of narrow in on the impact of completion type, or maybe lateral stimulation efficiency, if we want, or effectiveness, if we want to think of it that way. So the pinpoint outperformed the plug-and-perf counterpart by 22,000 barrels of production over the first 8 months. Now let's look at the pinpoint well number 2. Following the same procedure and accounting for its geometry, we can see that the model pretty much predicted what the well would do. In this case, there was no advantage of completion type. That once properly normalized, these wells look very similar, sort of apples to apples.